Alright, back with another flipped video for Honors Algebra 2. Today we're going to be looking at Lesson 2.8, talking about graphing linear inequalities. This is something we did a lot in Algebra 1. We're just going to cover it real quick, get the review out of the way, so again tomorrow we can kind of start doing some problems, figuring some other stuff out. So there's a couple things with linear inequalities. First of all, we got a couple choices. We have greater than, less than, greater than or equal to, less than or equal to. Okay, all these choices are going to change our graph in just the smallest of ways. First of all, if we have less than or greater than, like on this problem you can see here, we have less than. This is going to make our line be a dotted line, okay, because we can't include the line in our answer. It can't be solid because we can't include it. So again, it's going to be a dotted line. The way we graph this is the same way that we graph regular lines. We're going to start with our y-intercept. In this case, it's 4. Then we're going to use our slope. In this case, our slope is 2, up 2 over 1. And then we're going to draw our line. But again, we have a less than or a greater than. In this case, less than. There's no equal to. Okay, so it's going to be a dotted line. Not solid, because we cannot include it in our answer. So we have our dotted line. We're almost done with graphing this. Again, pretty simple thing that we've done before. Okay, we got to tell somebody looking at this answer which side of the line we're allowed to have. Okay, are we above it or are we below it? In this case, we are less than, so that's below the line. So to indicate which side our answers lie in, we're going to shade anything below that line. And now what that means is that any point down here, be it here or here, anything that's a point below that line, a combination of x and y values, we could plug into this inequality and it would work. So when we shade, we're giving a pictorial representation of which points would satisfy our linear inequality. Okay, as you probably guessed by now, if there's an equal to sign, it's going to have a solid line. It's basically like we're shading the line in. We can use those answers. So again, we're going to graph the same way. We're going to start our y-intercept, -1. Then we're going to use our slope, in this case down 1 over 2, -1/2. And here we get to make our line solid. Again, because those answers are included in our solution. We're basically shading in the spaces in between the line, in between the dots in the line. Okay, now in this case it's greater than, more than, above. Okay, we're going to shade above our line. Again, this means that any point in that region, any of these points here, doesn't matter, any point greater than that line, along with the ones on the line, since it's a solid line, these are all solutions to our inequality. If we plugged any of them in to this inequality here, for our x and y values, it would be true. Okay, so just a little review, some stuff we should already know. If it's greater than or less than, we got a dotted line. If there's an equal to, it's a solid line. We have to shade above or below our line to give a pictorial representation of what points would satisfy our inequality. Remember to do your guys' whisk. I'll see you guys tomorrow.